Dear all, we learned two key points last lesson, namely, two methods to distinguish both ends of a small three-phase asynchronous motor. 1. Use a multimeter in milliampere range. A pointer-type multimeter is required to distinguish. 2. Use a multimeter. A pointer-type multimeter is required, and batteries to distinguish. Today, we are going to learn something new. Asynchronous motors, also known as induction motors, are widely used in various aspects of national economic activity. Due to incomparable characteristics, these motors find their wide application. They have the advantages of simple structure, easy manufacturing, low cost, high efficiency, and reliability. In this lesson, we will continue to learn the content of the previous lesson. 4. Knowledge and skills supporting the task. Overview of electric motors. 1. Definition: an electric motor is a device that converts electrical energy into mechanical energy. 2. Classification: electric motors can be divided into DC motors and AC motors. AC motors are divided into synchronous motors and asynchronous motors. Asynchronous motors are further divided into three-phase motors and single-phase motors. 3. Nameplate of three-phase asynchronous motor. There are two types of three-phase asynchronous motors. The 6 output terminals of one group of stator windings are connected in star topology, while that of the other group of stator windings are configured in delta topology. The technical requirements and connection instructions on the motor nameplate must be referred to before selecting the wiring method. The relevant technical parameters of an asynchronous motor are usually indicated in the corresponding column on the nameplate, such as model, rated value, and connection method, which are important bases for the selection, installation, and connection, as shown in the figure on the right. 4. Technical parameters of three-phase AC asynchronous motor. 1. Model suggests a motor's product type, frame type, number of magnetic poles, etc. For example, in Y132M4, Y represents a cage asynchronous motor, 132 represents the height of the base center in millimeters, M represents the middle seat, L represents the long seat, S represents the short seat, 4 indicates the number of magnetic poles is 4. 2. Rated power refers to the mechanical output power on the shaft of an electric motor when operating at rated state, in kilowatts, kW. 3. Rated voltage refers to the line voltage applied to the stator winding under rated operating conditions, in volts, V. 4. Rated current refers to the line current in the stator winding of an electric motor when the rated voltage is applied to the stator winding and the rated power is output on the shaft, in amperes, A. 5. Frequency. The frequency of industrial electricity in China is 50 Hz. 6. Rated speed refers to the speed of the motor when the stator of the motor is subjected to the rated voltage at the rated frequency and the rated power is output on the shaft, in/min. 7. Power factor refers to the power factor of each phase winding of the motor during rated operation mode. The power factor usually ranges from 0.75 to 0.9. The power factor of capacitor-run single-phase asynchronous motors will be higher. 8. Efficiency refers to the ratio of the mechanical power output on the shaft to the input electrical power when the motor is fully loaded. 9. Insulation level specifies the allowable temperature of the motor winding and related insulation materials. According to the ability of different insulating materials to withstand high temperatures, 7 allowable maximum temperatures have been stipulated, which are arranged in order of temperature, Y, A, E, B, F, H, and C in descending order. Their allowable operating temperatures are above 90, 105, 120, 130, 155, 180 and 180 degrees Celsius above respectively. 10. Connection method refers to the power connection method for the winding of an AC asynchronous motor. Attention should be paid to the connection method of short-circuiting copper strips when wiring the motor. As shown in Figure 6.1.5 on the right. 6.1.5 Y configuration and delta configuration of three-phase asynchronous motor. Generally speaking, the Y configuration is adopted when the rated voltage of small and medium-sized three-phase asynchronous motors with power below 3 kW is 380 watts. The delta configuration is adopted when the rated voltage is 380 watts and the power is above 4 kW. According to the system license, the Y/delta starting method can be adopted for large and medium-sized wind turbine motors to reduce the impact of motor starting current on the power grid and motor windings. The content of this lesson has been fully presented. Let's review the key points of this lesson. Overview of electric motors. Definition. Classification. Nameplate of three-phase AC asynchronous motor. Technical parameters of three-phase AC asynchronous motor. That concludes this lesson. Thank you, everyone.